Yo, what is good, dev guys? Welcome back. In this video, I would like to start moving forward with the program inside of our procedural IK system. So the first thing I'm going to do is jump into my code here, go into animation. Let's open up this animation instance and .cpp. Now, I know someone mentioned in my comments that I should probably show what I am doing in my video before the video starts so that you can get a general idea of what's going to happen in the video. But to be honest with you, I'm not doing these pre-canned vegetable as tutorials. Like, we're in the garden with this. We're planting the seeds. We are picking. It's harvesting season. We're harvesting our different vegetables. We doing this shit from scratch. All right. So it's not like the rest of these tutorials that you see on YouTube. I'm going to go through the issues with you. I'm going to go through the steps that I would go through mentally if I was just programming the system myself. And you guys are going to learn how to fish. You're not just going to I'm just not going to give you the fish. You know what I mean? If you have been a part of my channel for a while, you understand that I don't do tutorials like everyone else does. So let's move past that though. Let's go ahead and start with this programming side. So the first thing I want to do is make a region for just this procedural IK code. That way we know what's ours and what is inside of Lyra by default. The first thing I want here is a reference to the character. So I'm going to make this U property. And this is just so it doesn't destroy itself without us, you know, saying so. I'm gonna make this blueprint readable. So blueprint read only, and put it in the category of procedural IK. Then I want to get a for declaration of our Lyra character. It's going to be a pointer, and we're going to call this the Lyra character. Set it equal to null pointer. And the next thing I want to go ahead and get is some of the transform data that we're going to be adjusting. And we're going to take this chunk by chunk. We're going to start with the sight and the relative hand transform. And that's going to be able to take where our sight transform is and make it relative to our camera, and then take our hand transform and make it relative to our sight. So let's go ahead and start typing those out. So I want a U property that's blueprint read only in the same category. I want to call this F transform. And this is going to be our relative hand transform. And then right underneath that, I also want another F transform. So F transform, and this is going to be our sight transform. And finally, let's make two U functions here that are going to be, I think we can keep them in C++ only. They probably don't need to be called in Blueprint. But if you want to do this kind of stuff in Blueprint, you can go ahead and make these Blueprint callable for yourself. I'm going to put this in a protected section so it's not accessible by any place else. And we also need to put these in a public section. Shift tab, public. And yeah, let's go ahead and make a void set sight transform function. And this won't take in any parameters. And then I also want to make a void set relative hand transform. And let's go ahead and just implement both of these puppies here. Generate definition. Generate definition. I'm going to actually cut this, and I'm going to put it into my procedural IK region that I have set up for myself here. So in this function, like I said, we want to take our sight and make it relative to our camera. So let's go ahead and start that. The first thing we want to do is check and see if our character is valid. If it's not valid, we want to return out of this function. So say if negate the is valid check and pass in our Lyra character. So if that's not valid, we want to return. And then we also want to only do this on the client. So we also want to check if our character is not locally controlled. So negate the Lyra character being locally controlled, return. Lastly, we want to make sure that we're doing this on just the client-based net modes. That means like listen server, standalone, so on and so forth. Because if you do this a certain way, like if I were to say if has authority, that would negate, like if not has authority, would negate a lot of things for me. So we want to make sure that we're doing this on the proper net mode. So I want to say if our net mode is not equal, so let's get our Lyra characters net mode, get net mode. And we want to make sure this is not equal to netmode underscore dedicated server. And I put a negate right here in the beginning on accident. But yeah, if we're not the dedicated server, let's go ahead and start doing this code. So we want to make a const f transform. And this is going to be our camera's transform. And it's going to be equal to, and this is actually getting my third person camera component, but we want to do get first person. Okay, so I see we don't have a getter for our first person camera. Yeah, let me see, get first person camera. Yeah, we don't have a getter for our first person camera. So let me go over to the character class. And let's see if we got a first person camera anyways. First person camera. It looks like in here, we're only using one camera. In my project, I believe I'm using the third person and a first person. So let me just double check that we're not using more than one camera in here real quick. Go to the constructor and yeah, we only are using one camera. Cool. So we can go ahead and go through with that call here. So we'll get the camera component and get the components transform. And then from there, we also want to grab the transform of our mesh, which is our character's first person mesh. So let's go say const f transform. And this is our mesh transform. And see here it's saying Lyra get mesh, but we actually want to get the first person mesh. So I'll say get first person mesh and then get that components transform. And we do have the first person mesh getter because we set that up inside the Lyra class. And if you don't have that set up, like if I might have set this up on my own, all you really are doing is just returning the mesh 1P that we created for our first person arms. But I'm almost 100% sure that we set this up. I could be wrong, but this is what the code looks like. They're inline functions, so there's no CPP implementation of them. We're just returning the things that we want to return right off the bat. Next step is we want to create this or fill this site transform. And this is actually not the right thing. We want to grab our ukismet math library and we want to say make relative transform. And we want to make a relative transform in between our camera transform and our mesh transform. Finally, we want to set the location of our our location value. So we'll say site transform dot set location, and we want to say the site transform dot get location. We want to keep the location the same, and then we want to add the forward vector of our the rotation of our transform here plus an offset. So let's say plus the site transform dot get rotation dot vector. This is going to get the forward vector of that rotation, and then we want to multiply that times a value called site offset. And we don't have that yet, but let's go ahead and make this real quick. And I believe we can make this a private variable that we will set via function. So I'll say float site offset, and I'll default this to 30. And going back to the .cpp, and that is pretty much all we need for this function. And this will go ahead and set our site transform with its relativity to our mesh and the camera. Next, we want to set our relative hand transform. So it's kind of like the same checks here. If we don't have a valid character, if the character isn't locally controlled, or if we are a dedicated server, we just want to bypass this code. So I'm actually going to copy this and then get rid of the junk in the middle that we don't need for this function. So same checks here. And then basically what we want to do here is make sure that we have a weapon that's equipped. So I'm not sure if I made this function, so let me double check. I can actually say if we don't have a current weapon, so I'll say Lyra character get current weapon. Nope. Okay, so we don't have a get current weapon function here, so I'm gonna plug it in right here, and then we'll make it inside of the Lyra character. So if this is equal to null pointer, or if our weapon doesn't have a first person mesh, so since our weapon is going to be a weapon-based class, this function will already exist, or the component will already exist for us. But since we don't have the Lyra version of that function, it'll be squiggled out for us, but we'll create it all. So if we don't have a valid first-person mesh on our weapon, we also want to return out of this function. And I probably should do this before we even check if we're a dedicated server. Yeah, I should keep it like this is fine. So what we're checking is the validity of our characters, our Lyra character, and the first person or the current weapon, and the weapon mesh for the first person side. So get weapon mesh 1p, which we will create. And if either of these are invalid, we'll just return and not run any more code. But let's create this get current weapon function here. So I got this section over here for custom code. I'm gonna do this weapon code here. And there is let's just make a U function that is blueprint pure category. Lyra character is fine. And we can make a function that returns a class, a U, actually it's a weapon base pointer. And we'll say get current weapon, making it const is fine. And for the implementation of this, just so we have the function, we'll return null pointer right here. And I'm looking at my source code here. We're not actually doing the implementation of this. We're actually using a force in line. So it's similar to this right here. So we're forcing line on this, and we're returning a value called current weapon. So this is going to be invalid until we make it. So I'll drop down here and make a U property. And this is going to be current. It's going to be of the type a weapon base. And set this to current weapon. And we also will need a way to set this current weapon. So I'll make a U function. U function that's blueprint callable in the category of Lyra character is fine. And we'll say void set current weapon. And basically all we'll do in here is set the value of that current weapon property that we created. So I'll say current weapon is equal to new weapon. And that'll handle that for us. Now what this is going to do is cause us to open up our character class, because where we want to call this function is on our weapon. So whenever the weapon begins play, it can do all this, do all of this for us. It can set itself as a current weapon. It can tell our character that it just equipped itself and other things like that. So I'm going to go down to weapons, and I'm going to open up the weapon.h and CPP just to have it. And on begin play, when we check if this is not the dedicated server, and then we check if we have a character here from our pawn owner, let's also call character.set current weapon. Set current, is that function is public, right? Yeah, it's public. So yeah, I should be able to call that. Let me go back. So let me just type it in myself. Set current weapon, and I want to see what it says here. This is incomplete. Is this incomplete? Cannot convert this to a const. Oh, since we made this const, we can't set anything on it. So let me take the const off. So now we should be able to do this right here. And with that, I think we have most of that set up on that side. So this is going to tell me that this is incomplete. So I'm just going to include the definition of a weapon base, which is Hashtag include weapons / weapon base.h. And here we should be good to go. Not seeing any squigglies. Yeah, so now we should be good to continue with our actual code for our relative hand transform. So I want to make a const f transform, and this is going to be our optic transform. And this is going to be equal to, well, in my project, we basically set this depending on what weapon you have equipped. So each weapon will kind of tell this system what optic is equipped to that weapon. But for now, what we could do is just get the weapon, get a socket transform on the weapon. So I'll say Lyra character, get current weapon, and I'll say get right here, instead of this, I'll say get socket transform. Is this, what's this telling me? Okay, we do need the mesh. So I'll say get weapon mesh 1p, and then I'll say get socket transform. And we want to give it a f name. So f name. And I know that the socket is going to be something very straightforward. So it's S_iron sights. And on each weapon, I believe that's the socket. So let's go ahead and just pass that in, tab over and complete that. Then from here, we want to say our mesh transform. So we need a const f transform, and we want to say our mesh transform is, if I could type, mesh transform, this is equal to our first person mesh, but we don't want to get the transform of the entire mesh. We want to get the socket transform. So say get socket transform, and then we want to pass it our hand, which we want to make this relative to. So let's say f name, and let's say our hand _r, because our weapon will always default to our right hand. You can make this a parameter if you want. That way you can set which hand you want to make this transform relative to, the optic transform. If you want to make it relative to the left hand, if you got a weapon that is attached to the left hand, then you can make this a parameter. But for this system, the weapon will be pretty much positioned in the right hand. So we want to say relative hand transform is equal to ukismet math library, make relative transform, and then we want to make our optic transform relative to our mesh transform. And this will go ahead and grab us the two transforms we need to kind of align our optic with the center of our screen. So in order to get this system to work, there needs to be something to trigger these two functions here. And since possibly on begin play, our character will not have a weapon equipped. Like in Lyra right now, you start with a weapon, of course, but we want this to be kind of dependent on a weapon being inside of our hands. And before I go, I think I'm forgetting something right here. So I need to say my Lyra character, and we want to say, actually, we want to take this and say Lyra character, if this is equal to, basically what we want to do is, if we don't have a Lyra character value field, or if this is not valid, then we want to do this. We don't want to return here. We actually want to go ahead and plug this value in here with this cast. So I'll take this and put it here instead. This will save us on casting to our Lyra character every frame, because technically the character won't change unless we have a system like our Marvel's Ultimate Alliance where you swap in between different characters. Then you can adjust that accordingly. But for right now, if we don't have this value, or I can basically what I want to say, if Lyra is equal to null pointer, then we want to fill it with this value here. Now, like I was saying before, we need a way to kind of synchronize our weapon equipped with our animation instance. So what we want to do is create a function on here to to basically be like a callback when we equip a new weapon. So let's put this in the public. This is going to need to be called from other places. So U function. Let's make it blueprint callable just in case we want to call this inside of blueprint. And this is going to be void on new weapon equipped. And this is not actually going to take in a weapon class. It's going to take in a float. And that float is going to be the new weapon offset. So each weapon will be able to tell this system how far to offset the relative transform of the sight from the camera. New weapon offset. So here, let's go ahead and generate a definition of this. And basically in here, we want to go ahead and set our offset. So I'll let that go out. So I think it's called sight offset. So we'll set our sight offset, update that, and then we'll create this F timer. So F timer handle, and this is going to be our sync weapon timer handle. And then I want to say get world, and we want to get the world timer manager or get timer manager. And then we want to say set timer using our timer handle we just created. So sync weapon timer handle. We want to use this object, and then we want to pass it the function that is on this class, which we haven't created yet, but we will. So this class, and then we want to say finalize weapon sync, and we will give it about a half a second. I've tested this, and about a half a second is a good number to make sure that even if your game takes a while to load, you'll still have time to sync this weapon. So let's create this finalize weapon sync function. And this could be protected. It's not going to be called from anywhere else. It can actually be private. So let's say void finalize weapon sync. And we'll generate that definition. And pretty much all this is going to do is set our relative hand transform. And it's going to set our sight transform as well. So whenever we equip a weapon, we'll call this on new weapon equipped. And then from our new weapon being equipped, we'll call this timer, and that will call these two functions that actually set up our sight transform for us. So let me connect this to the system. We need to actually connect our weapon being equipped to our animation system, since we're pretty much, when we equip our weapon is basically when the weapon begins play. So let's make a daisy chain function here. I like to call them a daisy chains function so that you don't have to cast to more than one thing. But we can go ahead and say, will this be blueprint callable? Yeah, we'll say U function. Let's make it blueprint callable in that category. And let's do this function void on player equipped new weapon. And we can pass in that same float, weapon offset. And let's generate this definition. And pretty much all we want to do here is make sure we have a valid first person mesh. So is valid weapon, or I think it's mesh 1P. Mesh 1P, check that validity of that mesh. If that is valid, we want to check that we actually have a Lyra, Lyra anim instance working in there. So Lyra anim instance pointer, and this is going to be our anim instance. I'm sorry, I forgot I can't do the auto completion from GitHub Copilot. Like it's like a weird thing that happens here. So anim instance, and I think I can do it right there. There we go. And so basically we're checking if we have a valid anim instance by using the anim instance that's inside of our mesh 1P. And we want to call anim instance, and we want to say on new weapon equipped and give it the weapon offset. So this will be called from our weapon. So our weapon knows about our character. Our character knows about our anim instance, but we don't want these. we don't want this to know about our anim instance at all. So we'll say character on player equip new weapon, and that means we need a value inside of our weapon for the offset of the mesh. So let me see here. Let's say edit defaults only. We don't need to make it blueprint readable. We never will read this value in blueprint. We might as well though, just in case you want to do this system in blueprint. So we'll go ahead and use the edit defaults only and blueprint read only, and we'll say float weapon offset. And I should probably make this more obvious. So weapon camera offset, and let's default this to 30 for every weapon. And that way we can go ahead and give it our weapon camera offset right here. And now if we're thinking about how the system is going to work, we will equip a weapon. This function gets called here to begin play. We go ahead and tell the first person mesh of our weapon to attach to our first person arms. Then we tell our character to set this as its current weapon. Then we also tell our character to call this on equip function so that our character can tell our anim instance, hey, we got a new weapon equipped. You need to do whatever you need to do whenever a weapon is equipped. So we'll set a timer, and that timer will call finalize sync weapon. And then here we'll set our site transform, and we'll set our relative transform. So with that, I believe we can go inside the editor and actually start setting up the animation blueprint so that we can see that this is working properly. So let's go ahead and debug here. Okay, that compiled successfully. Now let's set up the things that we need to set up inside the editor. So first, let's go ahead and I'm gonna just, if you don't already have a filter like this, you can just drop down this little filter thing here and hit skeletal mesh. And I'm gonna search for our rifle. That was it right there. I'm gonna double click on this, open it, and in here I wanna just make sure we have the correct, if I'm not mistaken, I wanna have the correct socket here that we use inside of the code. So we used, what did we use? I think we used S_iron sights right here. Yeah, so but for now, we'll just do this like this. So I'll right click on this root bone. I'll add a socket and I'll rename this to be S_iron sights. So exactly how we typed it. And then let's put this in a decent position. So we want the X value to be facing forward at all times. You see, well, ours is kind of backward, but this should still work. Just try your best to line this up. So if we go into the right side, and what I want to do is just make sure that this is actually in the middle of this mesh. And if we go to the right side, we can actually try to line this up as best we can to the center of the site itself. Or you can just put it on the top of this mesh right here, right there. So that's probably the best point to put it right there. So we save that. Now we got our weapon ready for this system. But I already set up the virtual bones for this system. So just in case anybody doesn't know how to do this, I'm going to delete those and we'll do them together. So what the first bone you want is the site bone. So that is parent of the child of the root bone. And then we'll add a virtual bone, and the target bone for this site is the hand R bone. So type in hand R. So here we want to name this to site, S-I-G-H-T. Then we want to right click on this bone, add a virtual bone, and then we want to get the target bone for the hand R again. And this is actually our hand R target, or our hand R virtual bone. So hand_R. And then one more time, right click on this, add a virtual bone, and say hand_L as a target bone, and we'll call this our hand_L bone. So now we want to go ahead and go to our anim layer BB class. So I'm going to go content, assets, retarget, base anim layer, and we want to use this item anim layers base. And here we're already in the function, but if you're not already in it, it's inside of item anim layers, and it's called full body skeletal control. So double click on that and you'll open up a window that looks just like this. Remember, we've used this before where we fixed all the errors inside of here. And here we're going from our transform modify bone of our weapon R, which scales it for us, and out to an output. So instead of going out to this output here, we actually want to cache this as the pose that we will plug into the rest of our data here. So I'm going to say this is Lyra retarget. So we'll take that, and then we need to pass that pose. So I'll say Lyra retarget. We need to pass that pose into a few nodes. So let's go from this Lyra retarget local to component, and then we want to use a node called modify or transform bone. The bone that we want to transform is our site bone. So let me just type in site, and we want this to be inside of bone space. So we'll set the translation and the rotation in the bone space, and then I'll take the scale and untick this exposes pin so it's not there. Then we want to get our main AnimBP thread safe, and let's get that relative and transform that we set up in the functions, and then let's split this. And then we want to pass in transform and rotation there and compile that. Moving forward, now we want to copy the location of our actual hand bone into our virtual bone. So let's say copy bone, and the source bone is our hand R bone, and we want to copy that data into our virtual bone. So this will transfer everything to our virtual bones. So that means the animation data will get passed to our virtual bone. So I'm going to untick exposes pin for all three of these so that this node can be clean. And then we want to just select copy translation and rotation. And then we'll do another copy bone, but this one will be for our hand L. So we'll copy the data from our hand L into our hand L virtual bone. And then I'll do the same thing, untick the exposes pin for these. And we only want to copy the translation. We actually don't want to copy the rotation. Next, we'll do another modified transform bone. And in this one, we want to make sure it's component space. And the bone we want to modify is a site bone. And we want to actually grab the site transform. So site transform, and let's split this. And we want to put translation and rotation into there. And instead of ignore, we want to say replace existing for both of these. And we want to go back to this one and also say replace existing. So this will replace the existing transform on the site virtual bone with this relative transform that we set up. Same thing with this and the site transform. Now, this is actually used for the aiming, and you'll see here when we actually finish this off that we'll be aiming right off of the bat. But the next thing I want to do is just go component to local right here, and I want to cache this as a pose, and we'll call this pose position set. Then we'll come down here and we'll take that position set. So let's take this set position, use cache pose, position set, and we want to go local to component. And now we want to use a node called toBoneIK. This will handle our IKs for our hand R. So let's go ahead and say enable debug draw, and let's pass in our hand R as the IK bone. This is the bone that's going to be controlling the chain. And now we want to set up our effector. Let's change this to bone space. And now we see we got this information here. Let's untick this as exposes pin. We don't want it exposed. We want to take rotation from effector space. And the effector target is our virtual bone for our hand R. So we'll take our BB hand R, and that is the target that will really be pushing this hand R bone around. Let's also remove this joint target as a pin so that this is a cleaner node here. Then let's do another one of these toBoneIKs. Go into that, and here, instead of hand R, we want to go hand L for our effector target. We want to do bone space, but instead of using the virtual hand R, we'll use the virtual hand L. And same thing, everything else is pretty much the same here. And now we can actually go component to local and then cache this as our hand IKs. So cache pose, call this hand IKs. Then this is what we actually want to output to our output node. So now we can take this node, and we want to grab this because we don't want to scale before we actually do our hand IK. So I'll take that. I'll bring it over here. And now we need to grab our hand IKs and pass that into a node here. This will automatically go local to component when we pass that in. And then we need to go from this to a local, so component to local. And then we want to get a default slot. But let's change this slot to full body additive pre-aim. This is just for the future. This is where we'll be doing all of the firing animations in this slot. And then we'll go from this pre-aim to here. Okay, and with that, we need to do one last thing. Let's go into our folder here and let's navigate to where our base anim BP is. And we need to jump in here. Uh-oh, you see we get a crash right here. If you're getting this crash, it's because right here, whenever the blueprint is trying to run this native update, we're getting an issue right here because this is still null right here. It was like the blueprint itself won't be able to get the character until it spawns. So it's running this code right here. If it's a null pointer, it's trying to fill it with this, but it still continues even if it doesn't fill it with this. So we're getting a null pointer right here. So what we need to do is say if basically if Lyra character is null pointer right here is equal to null pointer, then we need to return. So do that and recompile. Okay, that compiled successfully. Now let's jump into our first person animation blueprint here. It should open successfully and it shouldn't have any errors here. We need to go ahead and jump into this full body skeletal controls anim layer, and we need to pass this in pose into this output pose, because if we don't, there will be no data coming through the stream. And now we can actually jump into the viewport and play here. And you'll see once this loads up, we're automatically aiming down sight. You see that? Now we're able to use our sight here to perfect our aim. And you see that offset. We can show you what that offset does. So let's go to the rifle weapon. So let's go plug in shooter core. This is why you want to make this dynamic as well. So let's go to weapons. Let's jump into the rifle. Let's go into this rifle blueprint. And by default, that offset was 30, I believe. So let's look for offset. And let's set this to something like maybe 10 or something like that. And if we compile that and we hit play, now you see that weapon is a little bit closer to us. Like the sight is a little bit closer to us to the screen. But you see we are getting some clipping. And the way to fix that is to actually go to your editor settings, I believe. It might be project settings or editor settings. We'll search. Let's look for clip. So the near clip plane is set to 10. Let's set that to like 1 and see if that'll maybe fix that issue. This over here. And that was in project settings, just set in the near clip plane. And if I press play here, hopefully that fixes that issue. And no, it doesn't. I believe you need to restart the editor for that to take effect. So I'll give her a recompile real fast. So let's go ahead and do that. Okay, that's compiled successfully. Let's press play and see if that clipping issue is fixed. Now you see that our mesh is not being clipped through, and we can actually see what we're aiming at here. But the biggest problem is that we're aiming even when we're not ADSing. You see, when we ADS, we go to this right side. I still need to fix that curve. But when we ADS, that's when we want this actually to happen. So in the next video, we're going to set this system up to work when we are actually ADSing. So you see that off center like a mug. But yeah, so if you guys are ready for that, I'll see you in the next video. Peace.